The Xpeng Next General Iron, also referred to simply as Xpeng Iron, represents a monumental leap in humanoid robotics, combining cutting-edge engineering, advanced artificial intelligence, and aesthetic design to create a machine that is not only functionally sophisticated but also visually and behaviorally striking, appearing almost indistinguishable from a human in motion and presence, and poised to redefine how humans interact with robots in both public and private spaces. Standing at an impressive height with proportions designed to evoke natural human posture, the iron is crafted with a spine-like central structure, bionic muscles, and a network of flexible synthetic skin that covers an articulated metallic skeleton with a total of 82 degrees of freedom, allowing for an unparalleled range of motion in walking, gesturing, and fine motor tasks, while its hands alone are equipped with 22 degrees of freedom, enabling dexterous manipulation of objects, delicate interactions, and precise gestures that convey intention and presence, making the robot appear remarkably lifelike, whether it is holding a tool, extending a hand in greeting, or adjusting its posture as it navigates through complex environments, with each joint, servo, and actuator meticulously calibrated to produce fluid movements that mimic human biomechanics, further enhanced by subtle counterbalancing mechanisms and advanced torque control systems that allow for graceful, catwalk-style walking, smooth transitions between motions, and the ability to recover dynamically from disturbances, providing a convincing impression of natural balance and poise. The head of the robot is outfitted with a curved 3D display that functions as both an expressive interface and a source of visual feedback, capable of conveying information through soft animations, dynamic expressions, and subtle changes in illumination that correspond to the robot's internal state or task context, while the visual sensors embedded within the head provide a multi-layered perceptual system that integrates high-resolution cameras, depth sensors, and infrared imaging, enabling Iron to perceive its environment with extraordinary fidelity, detect obstacles, recognize objects, and interpret human gestures, facial expressions, and social cues, all processed through a sophisticated AI architecture built upon 3 in-house Turing AI chips delivering up to 3,000 tera operations per second of effective computing power, and a combination of large AI models including vision language transformers, vision language action systems, and vision language models that together allow the robot to process complex sensory data, understand contextual information, plan actions, and execute movements in real time, effectively giving the Iron the capability to perceive, think, and act autonomously in diverse scenarios while responding to dynamic changes in its environment. In addition to its computational sophistication, the robot's power system employs cutting-edge all-solid-state batteries that provide high energy density, enhanced safety, and longevity, enabling extended periods of operation without the need for frequent recharging, while minimizing risks associated with thermal instability, electrical faults, or mechanical stress, an essential consideration given the robot's intended deployment in commercial, industrial, and public environments. Privacy and ethical concerns are addressed through a dedicated, 4th law of robotics, which ensures that all data collected by the robot during interactions with humans or the environment remains local, never leaving the device, thereby safeguarding sensitive information and allowing users to interact with Iron confidently, whether in a factory, shopping mall, airport, or residential setting. Aesthetically, the Iron is designed for modularity and adaptability, allowing for different body shapes, proportions, and finishes to match the functional and cultural requirements of specific applications, while its synthetic skin is engineered to reflect realistic human textures and subtle variances in tone, contributing to the illusion of lifelike presence when viewed at close quarters or from a distance, and complementing the robot's mechanical underpinnings that remain hidden until intentionally revealed, as demonstrated during the public unveiling when Xpeng's CEO dramatically opened the robot's leg to reveal the intricate internal framework, servos, and actuators, conclusively proving that the lifelike movements were produced by sophisticated machinery rather than human performance, a display that captivated observers and highlighted the level of engineering mastery involved in the project. The Iron is intended for deployment across a wide array of real-world applications, including commercial customer service roles such as guiding visitors in shopping malls, providing information in airports, or assisting tourists at cultural sites, as well as industrial scenarios where the robot can perform inspection, monitoring, and operational support in factories or hazardous environments. With its dexterity, sensor suite, and AI allowing it to navigate complex spaces, manipulate tools, and respond intelligently to unexpected circumstances, effectively extending human capabilities while enhancing efficiency, safety, and consistency. XPeng's commitment to mass production by the end of 2026 underscores the company's ambition to make humanoid robots a tangible, accessible reality rather than an experimental novelty, with a software development kit (SDK) available for third-party developers to create applications, behaviors, and experiences tailored to specific industries, public services, or entertainment contexts, effectively creating an ecosystem in which the robot can continuously evolve, adapt, and improve its interactions with humans and environments. Visually, the iron evokes both familiarity and fascination, standing as a testament to the seamless integration of form and function, with each limb, contour, and sensor carefully crafted to evoke a sense of realism. From the lifelike articulation of its fingers to the gentle sway of its torso as it moves, the subtle flex of its knees and elbows under load, and the responsive motion of its head and eyes as it tracks humans or objects, all captured in a way that would allow it to blend into both everyday urban settings and high-tech futuristic environments without seeming artificial or uncanny. The combination of advanced materials, energy-efficient systems, and high-performance AI allows the robot to perform tasks ranging from simple repetitive actions to complex multi-step procedures that require problem-solving, contextual understanding, and fine motor precision, positioning iron not just as a tool, but as an autonomous agent capable of collaboration, assistance, and interactive engagement, bridging the gap between human expectations and robotic capability, and offering a glimpse into a near future where humanoid robots could coexist with humans seamlessly, augmenting labor, enhancing experiences, and redefining notions of presence and agency. The unveiling and subsequent demonstrations have also generated significant interest in the broader robotics and AI communities, with experts noting the sophisticated interplay between mechanical engineering, AI computation, and perceptual design, highlighting the potential for XPeng Iron to serve as a model platform for research in embodied AI, human-robot interaction, and advanced robotics manufacturing, and emphasizing how vertical integration, combining in-house AI chips, proprietary algorithms, and custom hardware, enables a level of performance, reliability, and scalability that is rarely achieved in other humanoid robotics projects worldwide. The Iron's development reflects broader trends in robotics, where mobility, adaptability, and intelligence converge to produce machines capable of operating in unstructured human environments, with XPeng leveraging its experience in electric vehicles, sensors, and software to translate automotive-grade precision, safety, and energy management into a humanoid robotic platform, resulting in a machine that is simultaneously functional, resilient, and aesthetically compelling, able to withstand physical stresses, environmental variability, and operational demands while maintaining a human-like presence that inspires trust and engagement. The potential for customization further enhances the robot's appeal, allowing industries and institutions to configure its appearance, interaction style, and functional capabilities to match branding, operational requirements, or cultural expectations, while the SDK encourages a collaborative development environment where new behaviors, responses, and integrations can be deployed quickly and safely, ensuring that the robot evolves alongside technological advancements and user needs. In sum, XPeng Next General Iron represents not only a technological marvel but a paradigm shift in the conception of humanoid robotics, merging advanced AI, precise engineering, energy efficiency, privacy-conscious design, and lifelike aesthetics into a single platform, capable of functioning autonomously in commercial, industrial, and social contexts, performing a range of tasks from navigation and guidance to complex manipulation, while inspiring wonder and redefining expectations of what a humanoid robot can be, embodying the near-future reality of intelligent machines coexisting with humans in everyday life, offering unprecedented opportunities for productivity, entertainment, interaction, and research, and signaling a bold step forward in the ongoing evolution of robotics, where the line between machine and life-like presence is increasingly blurred, and where XPeng Iron stands as a symbol of ambition, innovation, and the relentless pursuit of creating robots that are not merely tools but partners, assistants, and companions in the unfolding technological landscape, poised to leave a lasting imprint on society, industry, and the imagination of all who witness its capabilities, heralding an era in which humanoid robots transition from the pages of science fiction into tangible reality, reshaping our environment, our work, and our understanding of intelligent, autonomous machines, demonstrating that with vision, engineering excellence, and computational power, the dream of a truly capable humanoid robot is not only feasible but rapidly approaching full-scale realization in our everyday world.